This video will be an introduction to factoring out the greatest common factor, or GCF, from an expression. We're going to be focusing on expressions with two terms, so maybe something like 5xy plus 15x, or maybe something like 10x minus 20, and how to factor out the greatest common factor from each term. So another way to simplify expressions is what's called factoring, and there's a lot of different ways to factor depending on how complex your expression is. The key thing to notice in the word factoring is a factor. So if we remember factors, those are numbers that can be multiplied into the numbers that you're looking at. So if I'm talking about the factors of 15, I know that 1 times 15 is 15, and I know that 3 times 5 is 15. So that would be the list of factors of 15. 18 has a lot more. 1 and 18 works, 2 and 9 works, and then 3 and 6 also work. If we're talking about the greatest common factor, that would be the biggest number that those two have in common. So looking at this list, the greatest common factor of 15 and 18 would be 3. So again, the greatest common factor is the largest number that can be multiplied into both numbers that you're looking at. So for 15 and 20, the largest factor they have in common would be a 5. Now 12 and 24 have a lot of factors, being like 2 and 4 and 6 and 3, but the largest or greatest factor they have in common would be 12. So you always want to look for the largest number that can go into both. If you look at these bottom two examples, they're slightly different, and we can see that they actually have a variable in common as well. So a new idea to you is that variables can also be factors. So when you're looking for the greatest common factor, you not only want to focus on the numbers, but also any common variables they have. So for 50AB and 20A, not only is it 10, but we would also want to list A since they have that in common as well. Now for 12x and 16xy, the largest number that can go into each of those would be 4. And then the variable that they have in common would be x. So we call the greatest common factor between 12x and 16xy would be 4x. So let's get back to this idea of factoring now that we've situated what a factor is. Factoring is essentially working backwards from the distributive property. So you're really asking yourself, what could you have distributed to get the following? So if we look at this first answer, we have 20x minus 15. And I'm looking for essentially what could I have distributed to get me that 20x minus 15 essentially as my answer. So we're working backwards. Now, I know that whatever goes out in front gets multiplied by each thing on the inside. So that's where my greatest common factor is going to go. So between 20x and this minus 15, the greatest common factor between those would be 5. That's because 5 goes into both 20 and 15. Notice I didn't put 5x, and that's because both terms don't have an x, so that is not something they have in common. Now, think distributing is being multiplied. So what can I multiply 5 by to get 20x? Well, definitely 4 to get me to 20, and then I would need that x there as well. To get from 5 to this negative 15 or minus 15, I need to multiply by 3, and then to get me that minus sign, I would need to have a minus sign in here. Now, the good news about factoring is you can always check yourself by distributing that out and making sure you get what you started with. So 5 times 4x does in fact give me 20x, and 5 times this negative 3 or minus 3 would give me that minus 15, so we would be good. If we look at this next example, here's one where they actually do have a variable in common. I'm starting off by thinking, what could I have distributed to get me all of that? And a good place to start is the GCF. What did they have in common originally that's getting multiplied into both of them? So the greatest common factor here would be a 6, and then I also want to note that they have x in common. So that's going to get pulled out to the outside. Once I take it to the outside, it's no longer going to be on the inside. The inside shouldn't have anything in common anymore. So to get from 6x to 18xy, I would be multiplying by a 3, and I also need that y there. to go from 6x to a 6x, I actually don't need anything, so I would just be multiplying it by 1. And again, if I were to distribute this to check myself, 6x times 3y does in fact give me 18xy, and 6x times 1 would leave me with that 6x. Let's break this down and talk about the details that are happening here. To get me what's on the inside there, I'm essentially taking what I'm starting with and dividing it by that common factor that I'm taking out. So when I realize the GCF is 6x, I'm going to be dividing by 6x to tell me what goes inside of those parentheses, or essentially kind of like the leftovers. Now notice here I'm dividing by variables, and when you're dividing by variables, those cancel out the same way that numbers do. If I have 5 over 5, I know that equals 1. So 18xy divided by 6x, my x's are going to cancel. And that's where I got 3y. 18 divided by 6 gives me 3, and then I still have that y in its place. We can see that with this 6x and 6x, my x's cancel, and so would 6. 6 is divided by 6 would be leaving me with that 1 there. So these leftovers get inside of those parentheses. So the common factor on the outside, and any leftovers after dividing that out go on the inside. So if you want to try to kind of quiz yourself, you might want to pause this before I reveal the answers. Factoring out 3x plus 12, I'm looking for the common factor that I can take out of each of those. You might want to, when you first start, kind of give yourself an outline to follow of what your answer should look like. That helps me remember I'm working opposite or backwards from the distributive property. So 3x plus 12 have a greatest common factor of 3. If I divide out a 3 from each of those, I'm left with 1x, or just x, and then plus 4. For this next one, 10x minus 45, the greatest common factor between those two would be a 5. So dividing by 5 to get me what's inside would be a 2x, and then a minus 9. Let's do a couple with variables. So the greatest common factor between 9xy and 12x would be a 3x. And if I divide each of those by a 3x, remember your x's are going to cancel. So it's only going to be on the outside and not on the inside anymore. And that would leave me with a 3y and then a minus 4. Remember, you can always check yourself by distributing. So 3x times 3y would give me 9xy, and 3 times a negative 4 would give me a negative 12x. On this last one, notice there's a negative out in front. You really have two ways to do this, and I'll show you both. The greatest common factor between a negative 6ab and an 18b would be 6b. So I'm going to start by showing you factoring out a positive 6b. So if I divide each of those by a positive 6b, I would get, my b's would cancel, and I would get a negative 1a. I'm just going to write negative a. And then 18b divided by 6b, again, my b's cancel, and that would leave me with a positive 3. So that would be one option. Your other option, and you'd only really consider doing this when you had a negative out in front, is to instead take out a negative common factor. So let's see what this would look like if I factored out a negative 6b instead. I'm going to rewrite my original expression just to kind of have it close to look at. So if I were to divide by a negative 6b, my negatives would kind of cancel out in front as well as the b's, so that would leave me with a positive a on the inside. And then a positive 18 divided by a negative 6, again with my b's canceling, would leave me with a minus 3. Now, if you distribute each of these, they give you the original expression, which is why both of those would be correct. In the future, when you start using factoring to help you do other things, this way is going to be a little more beneficial for you. But for now, just factoring out greatest common factors, either of those would be acceptable.